Uh, as class, we learned the basics of pointers. Okay, now we will go little ahead of it. We will understand a little what better of pointers. Okay, yeah. Now let us see in these cases. Um, in the last class, we did only with the integers, right? Okay, now we'll handle different data types. I wrote here in this place what integer x. We studied what happens. 4 bytes have been allotted in Miranda. That's what we studied. Okay, 4 bytes have been allotted. I am writing one block is 4 bytes. Okay, I'm making one block is 4 bytes. One block is 4 bytes. I'm writing. Each byte has an address. Let's assume this is 115. That means this will be 119. We start with 4 bytes right now. 123. 127, 131, 135, and 139, and it's 143, 147. Okay, correct? I wrote integer x. 4 bytes have been allotted in the name of x. Okay, 4 bytes have been allotted in the name of x. If I say x is equal to 7, 7 is stored inside the 4 bytes in binary form. I say integer pointer p. It allots 4 bytes. P, 4 bytes. P is equal to and x. What is happening? What? I'm storing what? 115. Now I'm going to say here in this case is, I'm going to write here in this case, double D. If I write double D, what happened? How many bytes? 8 bytes. 8 bytes allotted, 8 bytes. 4 bytes I added, I made it what? 8 bytes. D. D is equal to 4.5. You are at 4.5. 4.5 is nothing but 45 into 10 raised to minus 1. In this case, 45 is stored in 6 bytes. 45 into 10 minus 1 is stored in 2 bytes. I am writing 4.5, but actually 4.5 is not stored as 4.5. 4.5 is stored as 45 into 10 raised to minus 1. 45 is called mantissa, minus 1 is called exponent. The mantissa is occupying 6 bytes and this is occupying what? 2 bytes. Now the next question comes to me is, I'm going to write it in this case, double pointer dp. Double pointer dp. I declared a pointer variable of type double. I declared a pointer variable of type double. How many bytes will be allotted? Only 4 bytes. Sir, D is also a double. DP is also a double. No, sir, DP is not a double. DP is a double pointer. The size of any pointer variable, is size of the integer in the operating system. The size of any pointer variable is the size of the integer in the operating system. Okay, make a note of that. Now, for x it is 4 bytes. For p also it was 4 bytes. Why? Any pointer we declared, only it will be allowed size of an integer. Why? Because all the pointer stores addresses are always what? An integer. All the pointer stores address is always what? An integer. That means if I say here in this case dp is equal to and d, what I'm going to store here in this case is I'm going to store 127 first address. That 127 is always what? An integer only was. I don't need to worry. Correct? Now the next here in this case is C. I'm going to say here P. What is the output I'm going to get? If we say P, what is the output I'll get? I'm going to get P means I'm going to get what? 115. DP. What is the output I'll get? I'll get 127. Star P. I am putting the indirection operator before the pointer. It is going to give me 7, right? P is 115. Star P means how much I'll get cut. I want to put star DP. What I'm going to get? I'm going to get 4.5. Sir, how? Okay. My 4.5 is actually stored in 8 bytes, whereas my 7 was stored only in 4 bytes. When I put a star before an integer pointer, it read only 4 bytes. When I put a star before a double pointer, it read how many bytes? What? 8 bytes. Therefore, address of a variable can only be stored by pointer of the same type. Okay, remember that. Why? Because when you put a star before an integer pointer, it reads only 4 bytes. When you put a star before a double pointer, it reads how many bytes? What? 8 bytes. It reads 8 bytes. That means, remember that if I declare a character variable, I want to declare a character variable. I want to say, for you to understand better, I declared a character variable ch. How many bytes? Only one byte is allotted. Only one byte. One byte, because these are bytes of four block of 4 bytes. Okay. If I say ch is equal to a, the binary form of 65 is stored here. Character pointer CP. How many bytes? What? 4 bytes. 4 bytes are not 1 byte. Why? Because size of any pointer variable is size of the integer in the operating system. Now I write it in this case CP is equal to and CH. What I stored here in this place, I stored what? 139. If I write a CP, what I'm going to get is that if I write CP, I'm going to get in this place is 139. If I say star CP, what I'm going to get? When I say star CP, CP is stored in 4 bytes. When I put a star before a character pointer, it will read only 1 byte. That means I'm going to get 65. If you put percentage D, I'll get 65. If you put percentage C, I'll get 8. Percentage C star CP will give me what? Correct? Okay. What I'm going to get? I'm going to get the binary form of 65, print in the character form or in the integer form. Correct? Therefore, when you put a star before a integer pointer, it will read only 4 bytes from the given address. When you put a star before a double pointer, it will read 8 bytes from the given address. When you put a star before a character pointer, it read only 1 bytes. That means size of any pointer variable is size of integer, because all the pointer stores what? Address. The address is always what? An integer. But when the indirection operator placed before an integer pointer, it will read 4 bytes for you. When the indirection operator placed before a double pointer, it will read what? 8 bytes for you. In the 8 bytes, 6 bytes will be interpreted as a mantissa, 2 bytes will be interpreted as what? An exponent. When I put a star before a character pointer, it will read how many byte? What? 1 byte. Therefore, once again, I would like to remind you, address of a variable can only be stored by pointer of the same type. Why you cannot store the pointer of it? That means can I say P is equal to and D? Can I write it? When I say and D, what I'm going to get? When I say and D, I'm going to get 127. Can I store it inside P? If you store it, what will happen? When you put a star before a P, it is going to read only 4 bytes. It's not going to read 8 bytes. From 127, my data is present in 8 bytes. And in the 8 bytes, 4 bytes, 6 bytes has to be read as a mantissa, 2 bytes has to be read as what? An exponent. Therefore, if you do it, you might get a garbage value. Therefore, they are not allowing you to do this. This statement cannot be written. Address of a variable can only be stored by pointer of the same type. Pointer of the same type. Got it? Let us see here in this case is what is going to happen. Let us see here. Okay. Now I'm going to say here in this case, see, look at this. Can I say here right now, star p is equal to and x? Can I write it? X is an integer. Can I write star p is equal to and x? No. Why? Because and x will give you an address. Star P refers whom? P refers 115. Star P refer this. This is an ordinary variable. Cannot store what? An address. Not possible. Can I say P is equal to and X? Yes. Why yes? Because and X will give you 115 can be stored by a pointer variable. So if you like my session, kindly share, subscribe and like. Can I say here in this case dp is equal to and x? No, why? And x will give an address of an integer pointer. I cannot store it in a double pointer variable. I cannot store in a double. Address of a variable can only be stored by pointer of the same type. Okay, remember that. Now let's see solve this problem. Okay, you can take this in your notebook and I'm going to write this something on this, and what do you do? Just write, solve it for me. I'm going to write like star p is equal to star p plus star dp minus star c. Okay, star dp is equal to star dp plus star cp minus star p. Star cp is equal to star cp plus 4. First of all, there is a question must have written in your mind. Sir, can I write it? Can I store a double pointer into integer pointer? No, here you are not storing a pointer, you are storing a value. When I write star p, am I going to get a value or an address value? Star dp value. Can I add an integer and float? Yes. Can I add an integer and double? Yes. Result will be what? A double. Double minus. When I say star cp, am I going to get a character? No. I'm going to get an ASCII value of the character, right? Now, tell me, if I write this expression at the end, what will be the output of my x? What will be the output of my star p? What will be the output of my d? What will be the output of my star dp? What will be the output of my ch? What will be the output of my star cp? Okay, write in a notebook and get the output. Okay, pause the video and go. Okay, so let us see. Okay, what you have solved it. Star p. P is how much? 115. Star p would be what? Value at 115. That is 7. Star c dp. dp is 127. Star dp is what? 4.5 minus. Star cp. cp is 139. Star cp is value at 139. Is what? 65. You don't get a here. 65. 7 plus 4.5 is how much? What? 11.5. 11.5 minus 65. How much I'm going to get? What in this case? 53.5. Correct? 53.5. I need to store. This result is going to be 53.5. I want to store. Where I want to store it in what? Star p. Whereas star p is an integer. Therefore, it is going to store only 53. Now, star dp. How much I get? Star dp. dp is 127. Star dp is what? 4.5. Plus star cp 65. 69.5 minus 69.5 minus 53. Not 53.5, 53. Why? Because just now we saw we put what? 53 inside. Now I say how much it becomes what? This is supposed to be 12 plus, that is 16.5. 16.5 will be stored. Where will be stored in what? Star dp. Now I say cp. What is cp? cp is 65. 65 plus 4 is 69. I store in 69. If I print it, x means what is the output I get? X means I'll get 53. Star P means how much I'll get? 53. Why? D is how much what? 16.5. Star DP is how much what? Same, 16.5. This is what? CH is 69. That means CH is 69. Star, this is what? 69. If you put percentage C, you'll get the corresponding character of 69. Okay, now? Got it? So again, I would like to ask you the last question to you. If P is an integer pointer, can I say star P is equal to star DP? DP is a double pointer. Can I write it? Yes. Why? When I say star DP, you are not copying the address. You are copying the value. In this place, the value of star DP is 127, star DP is 16.5. You are putting the 16.5 in star P. Star P means how much it is what? 115. Star P is here. You are putting the 16.5, but 16.5 will not be stored, only 16 will be stored. Can I say P is equal to DP? No. Why? DP is what? DP is holding an address of a double, cannot be stored by an integer pointer. Cannot be stored by a integer pointer. Remember that, okay? Now, can I say here in this case, P is equal to CP? Can I say? No. Why? CP is a character pointer. Character pointer cannot be assigned to what? A integer pointer. Can I say star P is equal to star CP? Yes. Why? Star CP will give me what? It's 69. Can be stored here in star P. P is 115. Star P is here I can store. See, remember the statements valid and what? Invalid statements. Okay. Therefore, again, I would like to iterate. Address of a variable can only be stored by pointer of the same type. If you want to store an integer pointer, you need a pointer variable of type what? Integer. If you want to store a float pointer, you need a pointer variable of type what? Float. Okay. Next. The size of any pointer variable is size of the integer. All the pointer stores address. Addresses are always what? An integer. But when you put an indirection operator before an integer pointer, it reads 4 bytes. When you put a indirection operator for a double pointer, it read 8 bytes. When you put an indirection operator before a character pointer, it read how many byte? What? 1 byte. Got it? I hope that you understood this. Yeah. Okay. Now we will learn a very, very important concept of this pointer. Okay. Understand this carefully. Okay. We said X is 7. P is equal to and X. Double D. D is 4.5. Is spread out in 8 bytes. Remember. DP is 4 bytes. DP is equal to and D. What I stored what? 123. Now look at this. Can I say here variable of type void? Can I say void V? Why no? Is it void is a data type? Yes, of course, void is a data type. But how many bytes will be allotted for it? 0. You can't name 0 byte with V. Here you named 8 bytes with D. You named 4 bytes with what? X. 0 bytes with V. Can't be done. So then next question is, can I say void pointer VP? Can I declare a pointer of type void? Yes. Any pointer you declare. How many bytes will be allotted for you? What? 4 bytes. Any pointer you declare. How many bytes will be allotted for you? What? 4 bytes. Size of integer. But then an integer pointer is capable of storing an address of an integer. A double pointer is capable of storing an address of a double. Then a void pointer is capable of storing an address of what? Address of any variable. Any variable. VP is equal to and X is possible. Sir, P is equal to and D is not possible. But VP is equal to and X is possible. Why? The void pointer can store any address. A void pointer is called as a generic pointer. What is the meaning of generic pointer? It can store any address. It can store what? Any address. But the condition is an indirection operator cannot be applied before the void pointer. What do I mean by this? I am going to say here in this place P, I am going to get 115. I am going to say here in this place dp, I am going to get what? 123, right? I am going to say here in this place vp, I'm going to get what? 115. So then if I say here in this case star p, what is the output? I will get what? 7. If I say star dp, what is the output I'm going to get? 4.5. But if I say star vp, I'm going to get an error. Why? Because when I put a star before an integer point, it will read 4 bytes. When I put a star before a double point, it will read 8 bytes. When I put a star before a void pointer, how many bytes will read what? 0 byte. You can't read it. Therefore, you can get what? An error. Therefore, the indirection operator cannot be placed before the void pointer directly. Then, sir, next is what? I'm going to say. Then, how to get a value? Why do we use a void pointer? How to get a value? Void pointer can be used to hide the data. Now, if you want to extract a value out of this, you must know this VP storing what type of address. If I say here in this case VP, I get 115, right? If I say here in this case VP, I'm going to put here in this case integer star. What is it? Typecasting. By typecasting, what you're doing? You are telling the system to store the VP in a register of type what? Integer pointer. Therefore, now by this statement, I am going to get 115. But what is the difference? Here the 115 is stored in a register of type void pointer. Here the 115 is stored in a register of type what? An integer pointer. Now if I say here star integer star VP, I'm going to get what? That means if you want to extract a value from a void pointer, you must know what type of data is stored. Based on that, you have to typecast. What is typecasting? By typecasting, you are telling the system store the result in a register of type the data type. Okay, so then can I say right now VP means I got 115. Can I typecast into a double pointer? Yes, you can typecast it. But what I'll get it? VP storing 115. I'll get 115 only. So then what about star, double star? What I'm going to get? Oh, by writing double star, what you're saying? You are storing a data of type what? Double in 115. Therefore, from 115, it is going to read right now 8 bytes. If it reads 8 bytes, and in the 6 bytes is mantis or 2 bytes is exponent, I'm going to get a garbage value. Garbage value. That means whenever you typecast a void pointer into a different data type, you will get a result, but you will get a garbage value. You will get what? A garbage value. Okay. So that means, can I say here right now, VP is equal to DP? Can I say it? Yes. Because DP is holding what? 123. Any address can be put inside 123. Correct? Now I say, I am going to say here in this case, DP. What I get? 123. VP. What I get? 123. What I say if I say here right now star DP, what I get? 4.5. If I say star VP, what I get? Error, right? If you want the result, what I should do? I need to typecast. I typecast into double star VP. What I'm going to get? 123 only. But what is the difference? This is stored in a void pointer. This is stored in a double pointer because you stored in a register of type double. If I store star double star VP, what I'm going to get? What in this case is 4 point. Got it? Sir, no sir, I will typecast into an integer. Integer star VP. What I'll get? 123 only. If it's a star integer star VP, what I'll get? Garbage value. Because it will read only 4 bytes. Whereas my data from 123, it is stored in how many bytes? What? It's stored in 4 bytes. Therefore, a void pointer is called as a generic pointer. Any address can be stored inside. If you want to get a value, you need to what? Typecast it. And appropriate typecasting is needed. and inappropriate typecasting would produce garbage value. Now, let us see the next one. Okay, the question comes, can I say integer pointer p is equal to index? Can I write? Yes. By writing this, what we're doing, x is a variable, 4 bytes have been allotted, p is a variable, 4 bytes have been allotted, p is equal to index 115 stored. Okay. Now I write it in this case. I am going to say here in this place, p means I'm going to get 115, correct? Star p means I'm going to get what? 7. At the line of declaration, the star is not with the p, star is with the data type. Then maybe next question comes, can I say star p is equal to and x? Can I write it? Why? The star p refers x. X cannot store an address. X can only store what? A value. Okay. Therefore, at the line of declaration, you can also initialize. Doesn't matter. But remember, what you are doing, you are not saying star p is equal to index. You're saying p is equal to index. Remember. Okay. Because at the line of declaration, the stars with the data type. Okay, sir. I'm going to give you something on this. Please write it and get the output in your notebook. Okay, please get the output in your notebook. Please get the output in your notebook. Pause the video, write this and get the output. Okay, slowly scroll and write this. Okay, done. I hope you made an effort. Okay, so what is the answer? Let us see very fast. X is 5, y is 7, p is what? And x. Address of x is 115 is here and 119. Star p is equal to 40. P is 115. Star p is what? 40. X is how much? What? 40. Y is how much? What? Y is 7. Star p is what? 40. P is equal to and y. Star p. P is equal to and y. What is stored here? What? 117. Star p is equal to 50. What is stored? I stored what? 117 ke andar what I stored what? 50. Now x is how much? What? X is 40. Correct? Y is what? 50. Star p is what? 50. So the answer is what? I'm going to use the same thing to explain another concept. Okay, let us go to this concept. Okay, now let us see. I have written like this: integer x, and my x is equal to, or x is equal to 3, and x is equal to 7, x is equal to 9. I'm going to print the x. What I'll get? I'll get 9. Why? A variable we can store only one value. Which value will be stored? The last value will be stored. Correct? Yeah, this was right. Okay, done. Now in C, we have a keyword called const. I can put a keyword const before a variable declaration. If you put a const before it, what is the meaning of this statement is x is an integer constant. X is an integer constant. Constant means what? Whose value cannot be changed. Therefore, what you have to do? You have to initialize at the line of declaration. Done. Once you declare a variable as a constant, you have to initialize at the line of declaration. Done. Now x is equal to 7. Not possible. Why? Because you said x is a constant. X is equal to 9. Not possible. What is output of x is what? Therefore, a constant variable has to be initialized at the line of declaration. Once it is initialized, it cannot be changed. It cannot be reinitialized. Okay. Now let's go. I want to put here in this place. See, this is my declaration, right? I want to put it in this place const. What is the meaning of this statement? What is the meaning of this statement is p is a pointer to an integer constant. Therefore, who is a constant? P is an integer. P is a pointer to an integer constant. It's a pointer to integer constant. That means the stress is not on the p, is on the this. What it says, p is going to hold an address of a constant. Address of a constant. Even though x is a variable, but it will be treated as a constant. Therefore, initially my x is 5, y is 7, and p is and x. I can write it. I don't need to initialize at the line of declaration. Why? Because p is not a constant. It is saying the address stored by p is a constant. P is a pointer to an integer constant. Star p is equal to 40. P is 115, star p is here. I can't store the 40 here. Why? Why I cannot store? Because you said it is a constant. P is storing an address of a constant. X, what is output? I'll get 5. Y, what is output? I'll get 7. Star P, what I'll get? 5, 1. P is equal to and Y. Yes, you can write. 119. Star P is equal to 50. Not possible. Why? Because we say P is a pointer to an integer constant. Not possible. X, how much I'm going to get? 5. Y, how much I'm going to get? What? 7. And here I'm going to get what? 7. This is called pointer to a constant. Sir, x is a variable. No worries. Because by this you are saying p is going to hold address of a constant. So that means, can I say here after this statement, can I say here in this case x is equal to 90? Yeah, you can write. I don't know problem. Why? By this 90 will become x will become a 90. Doesn't matter. Through the pointer you can't change. Through the pointer you can't what? Change it. Now look at this. Now we are going to do something different. Something with the same thing. The same thing before I write something different. The same thing can also be written by you. This statement can be written by you as integer constant star p. Both of them. P is a pointer to a constant integer. P is a pointer to a constant what? Integer. Both are same. They are saying that it's a constant what? Integer. Okay. Now look at this. Simply I'm going to say it's the position of the star. This I'm not in this way you can't write it. I'm going to say in this place instead of writing a star here, I put the star here. What happens? P is a constant pointer to an integer. P is a constant pointer to an integer. That means the stress is where? The stress is on P is a constant pointer. P becomes a constant. Therefore, it has to be initialized at the line of declaration. Now I say P is equal to and x. P is equal to what? And x. Can I say P is equal to and x? No. Why? Because it is a constant. This became a constant. Since it became a constant, you have to initialize at the line of declaration. Once it is initialized, it cannot be reinitialized. Okay. Can I say star p is equal to 40? Yes. Why? P is 115. Star p is here. This can become 40. You have nothing said about it. X. What is output I'll get? 40. Y. What is output I'll get? 7. Star p. What is output I'll get? 40. P is equal to and y. What I'll get? And y means how much I'll get? 119. Star p is equal to 50. Now, can I say p is equal to and y? No, why not? Because p is a constant. You can't change what the address. Star p is equal to 50. Star P is equal to 50. What is star P is equal to 51? P is holding what? 115. Star P is 50 means 50 is here. Now X. This is possible, remember. X, how much I get? 50. Y, how much I get what? 7. Star P, how much I get what? 50. That means throughout your program, P will hold the same address which was given in the beginning. It is called constant pointer. It is called constant what? Pointer. Okay. Now let's recap it. We talked about one is a pointer to a constant, other one is a pointer, constant pointer. In pointer to a constant, what we said was the using the pointer, I cannot change the value. In constant pointer, we said the pointer cannot be changed. The pointer cannot be what? Changed. But using the pointer, I can change the value. Okay? Understood the difference? Yeah? Okay? It's very useful for you in this. Now, let us understand what is a pointer to a pointer. Okay? So far, we saw a pointer variable. We saw a pointer. Okay? Now, we are going to see pointer to a pointer. Pointer to a pointer. Okay? Let us see what is the meaning of this. Now, I wrote here in this place integer x. Correct? We know. If I write integer x, what happens? I create a memory. I am assuming each block is of 4 bytes. Okay, now each block is of 4 bytes. Okay, not 1 byte. Because I don't want to write 105, 119, 123, 127, 120, 21. Right? I wrote integer x. If I write integer x, for x, 4 bytes have been allocated. This is 4 bytes. 115, 116, 117, 118. I am writing here in this place x is equal to 7. No, 7 is here. Now I write here in this place and x. When I write and x, I'm going to get the first address of x, correct? Which is called as a pointer, which is stored in a register of type what? Pointer. Therefore, if you want to copy, you need a, if you want to copy this, you need a pointer variable. By this, you declare a variable called p. In that p, what you put what right now? 115. Right? Now I wrote it in this place. X means, what is output? I'm going to get 7. If I say p means, what is output? I'm going to get 115. If I say star p, what I'm going to get what? Star p means value at 115. What is value at 115 is 7. Remember, it's going to read 4 bytes because an integer point. Right? Now, sir, I'm writing it in this place. And what? P. See, and P. P is a pointer variable. It's holding an address. It's holding a pointer. And P means address of P. I'm going to get 119. I want to store. If I want to store, I need a variable. The variable is a pointer. But the pointer is slightly different. It is a pointer to a pointer. Therefore, you will use double star. Why? P is holding an address of x. X is ordinary variable. Ordinary variable address will be held by a single pointer. The address of a single pointer will be held by a double pointer. dp is equal to and p. By this, what I put in this place, I put 119. Correct? Yeah. Now look at this. Very important for you. If I say x means what I'm going to get 7. Correct now? P means what I'm going to get? P means I'm going to get 115. dp means what I'll get? 119. Now the next is, if I put a star dp, dp is 119, star dp means value at 119. What is value at 119? 115. What is 115? Is an address of ordinary variable. Now if I say here in this case, star p, what I'll get? P is 115. Star p means value at 115. How much I'll get what? 7. Now look at this. If I say DP means you got 119. Star DP means you got 115. Star DP means how much I'll get what? I'll get 7. That means in a double pointer, this is a double pointer, right? In a double pointer, if you apply a single indirection, it will refer a single pointer. In a double pointer, if you apply two indirections, it will refer a ordinary variable but via the single pointer. What do you mean by via the single pointer? Double pointer can never come to the ordinary variable directly. It will always come via whom? Via the single pointer. That means DP gives you 119. Star DP will give you value at 119, that is 115. Star gives you what? 7. You understood this? I hope that you understand. Okay. Therefore, whenever you talk about a double pointer, the double pointer can only store an address of a single pointer. The single pointer will store an address of a ordinary variable. Can I store in a double pointer ordinary variable? No, not possible. What do I mean by this statement? Can I say dp is equal to and what? X? No. Y? And X. X will give you what? And X will be 115. 115 is an address of ordinary variable which cannot be stored by this. It is wrong. So that means my next question comes to you. Can you please tell me? I'm going to say here right now, I'm going to declare another variable y. Let's say y is equal to 3. I got a block called y is 3 here, right? Can I say right now, p is equal to y? Can I write it? No. Why no? Y is an ordinary variable, cannot be the value. Ordinary variable will get a value. The value cannot be stored by a single pointer. Pointer can only store what? An address. Can I say star p is equal to y? Yes, y. Star p refers whom? P refers 115. Star p refers what? Value at 115 becomes y means what? It became what? 3. Next is, can I say dp is equal to y? No. Why? Because y gives a value. Value cannot be stored by a double pointer. Can I say dp is equal to p? What is p? P is 115. 115 cannot be stored by dp. Why? Because 115 is an address of an ordinary variable, whereas dp can only store an address of a pointer variable. Can I say star dp is equal to p? What is p? P means I'm going to get what? 115. Star dp. dp is 119. Star dp is value at 119. I can store 115 here. Same thing. I told you, when you put a single star before a double pointer, it refers the single pointer. It refers the single pointer. Next. Can I say star dp is equal to y? No. Why no? Y is a 3. 3 is a value. Cannot be stored by star dp. dp is 119. Star dp is here. I can't store 3. Not possible. Can I say star dp is equal to y? It's y. Y means I'll get 3 is a value. Star dp. dp is 119. Star dp is value at 119 and value at this. How much I get what? Here I store what? Now let us see here. I'm going to give you a problem. Please solve it. Okay. Please write it down. Don't just keep on watching the video. Please write it down. Integer x is equal to 7. Integer y is equal to 3. Integer pointer p and pointer q. P is equal to and x. Q is equal to and y. Integer star dp. dp is equal to and p. It is equal to and what? P. Right? Now look at this very carefully. dp is and p. Now I am going to say star dp is equal to Q. Write down. Star dp is what? Q. Next is, I'm going to say here, star dp is equal to x plus y. Now I'm going to say q is equal to and x. Now I say here in this case, star dp is equal to x plus y. Correct? Star dp is what? X plus y. Now give me the output of x, y, star p, star q, star p. Please give me the output. Okay, this is what you need to give me. Write down, slowly move and write it down and get it. Okay, please solve this. It will help you to understand, revise it. I hope you made an effort. Let us see what is you made it. Okay, so let us see what you've done is right or wrong. We had x, we had y, x is 7, y is 3, 115, 119. P is here and Q is here and DP is here. This is an address, okay? Let's say 215, 219 and 223. Now P is equal to and x. What do you put? 115. Q is equal to and y. What do you put? 119. DP is equal to and P. What do you put? What? 215. Q means how much I get? 119. 119 is stored in star dp. And what? Star dp. Here what is stored? What? 119. Correct? I'll erase it and write it so that you understand better. See, it became 11. Now I say x plus y. How much? 7 plus 3 is what? 10. 10 is stored in star dp. dp is 215. Star dp is 119. Star dp is here. It became what? 10. Q is equal to and x. Q is equal to and x means what is stored in this place? What? And x means how much you get? 115. X plus y. How much? X plus y is how much? What? 17 is stored in star dp. dp, star dp and star dp. How much it is? What? 17. Now we say x means how much I'm going to get? 7. Y means I'll get 17. P means I'm going to get star p. P is 119. Star p is what? 17. Star q is how much? What? 7. Why 7? Because q storing what? 115. Star q means how much you'll get? What? 7. Star dp is 17. Why 17? dp is 215. Star dp is what? 119. And this is star dp. Okay. So if you have not solved it, if you have not understood, not correct, I give another problem. Okay, please solve it. xp is equal to and x, yp is equal to and y, zp is equal to and z, dp is equal to and xp. Right now, I write xp is equal to yp is equal to star dp, star dp is equal to star dp is equal to zp. Okay, star zp is equal to x plus y plus z. Star dp is equal to x plus y plus z. Star yp is equal to star xp plus star yp plus star zp, right? Okay, well done. Okay, now you need to give me the output of x, y, z, star xp, star yp, star zp, star bp. Now, this output I want. What you do? Solve it, write it by yourself, okay, and then solve it and see by yourself. If you are then, if you want to verify your answer, type it and see. Okay, now slowly scroll, okay, and write it down. If you are writing, and pause the video. Okay, see, this is after this, and this is after this. Okay, guys, thank you so much.